Hi, I'm Craig Young, Principal Security Researcher with Tripwire's Vulnerability and Exposure Research Team. In this video, I'm going to demonstrate how to use a firmware update to audit a router's security. The first step here is to download the latest firmware from the vendor and extract it. Once we've identified the system update file, we can use the open source tool Binwalk made by Craig Hefner to scan through the file looking for known file formats. Binwalk's output lists the offsets into the file where it's found magic numbers or potential file headers. In this case, we can see that 128 bytes into the file, there's a Linux kernel, and the file ends with a squashfs file system. Binwalk's extraction also automatically carves the file based on these offsets and puts the resulting chunks into a directory named based on the input file. We can now use 7-zip to extract the recovered squashfs file system from the firmware image. By accessing the squashfs file system, we're able to get a close look at what services might be running on the device, as well as what files might get served from the web interface. Now that we've extracted the file system and located the web root, which in this case is just /www, it's time to enumerate those files and try and figure out which ones are accessible on the web server without authentication. A bash for loop to run curl from the output from either ls or a find command can be very effective at doing this. Note that I use curl-v to get verbose information and then use bash syntax to redirect the standard error output on standard out and then grep for the HTTP 1.0 200 response code. But really what we're interested in here is the name of the files. So the output has been directed to dev null, and using the ampersand operator, we're able to just print out the names of any files where we've gotten this 200 response code back. In this case, we're seeing that there's unauthenticated access to a lot of different graphics files and JavaScript files. But the most interesting file that's coming up in here is this one CGI file there, unauth.cgi. It turns out that this script is essentially an error message for saying that you were unable to log into the router. Because the login error itself should not trigger another login prompt, the unauth.cgi file was actually added into a whitelist on the embedded web server. It turns out, however, that the whitelist really wasn't designed all that effectively, and it becomes possible to use URL query parameters to trick the router into thinking you're requesting the whitelisted file when you're actually requesting some other content. The use of frames on this site, however, makes it so that our authentication bypass does not appear to fully work, but by using the burp intercepting proxy, we're able to easily demonstrate that we can in fact log into the router without authentication. The initial request contains a bypass string already, so it can be forwarded as is, but we can see then that as the additional frames load, we need to manually add on $unauth.cgi to bypass authentication for each of these requests. It's important to note at this point that we're actually able to use this authentication bypass with post requests as well, and that eventually we do get to a proper login screen for the router without having entered a password. At this point, we can go back to the router firmware and look to see what interesting authenticated content there might be. File names containing the word hidden or debug are often a great place to start looking. The most interesting file, though, of course, is this ping6 traceroute6 hidden file, just because ping does mean that it's running a command on the back end, and this opens up the door to command injection vulnerabilities. Although we can't access this page without credentials, we can use our authentication bypass string to bypass the login prompt. Next, we'll attempt to ping the IPv6 loopback address just to confirm that we have actual functionality with the ping command using our authentication bypass. To do this, I just need to add in the unauth.cgi string into an appropriate part of the requested URI. We can now see that the router is processing the request, and we've been redirected to re-request the ping page, where we can now see output from our ping command. Next, I can try a simple parameter injection just to see whether or not the application is filtering input to the ping function. Again, the bypass string must be added into the request before it's forwarded along by burp, and then we can see in the output that our ping has actually been run twice now, and so it has in fact properly injected the -c2 parameter to the ping command. Next, we'll attempt to inject a completely new command into the IP address field by using the semicolon shell meta character. If the injection is successful, this command will result in spawning a telnet server on port 1337. The bypass string must once again be inserted manually using Burp Suite, but from there we can switch back into our terminal and check whether or not the bind shell has loaded. And we're in. We now have a root shell, and we're able to get there without having any kind of authenticated access to the router. The only thing necessary was access to the web management interface and a firmware image.